let's prove this identity together. We are required to prove that the left-hand side is equal to the right-hand side. For 10 marks, I don't think it's a child's play. Because you can see here you have 6x, you have 4x, you have 10x, you have just x, which means there is a lot of breaking down that is going to take place in this question. So how do you start? Of course, we have to take the left-hand side because it's easy to simplify than to complicate. Now, because we really want to break down that 10 to be in terms of 6 and 4, which means this side must be just taken as it is. So we have that, then minus, then we of course 10 is made of 6x plus 4x. So this is what we have, then plus 2 sine squared x. Now, you can see that this is a compound angle for cos, so we really need to expand it. So while we're expanding that thing, let's just keep this one as it is. So minus, so let's expand this one. You have cos 6x, then cos 4x, then minus sine 6x, then sine 4x. Then we have done, then plus 2 sine squared x. So we have this one now. So the idea is to really try to distribute this negative to the inner function. So whilst we are doing that, let's keep this one as it is. This is 4x. So taking this negative through this inside bracket, so we will have negative cos 6x cos 4x, then plus, because negative and negative gives you positive, then 6x, then sine 4x. Then don't forget to add that one over there. Now, what do you notice? I notice that this is the same as this. So since they have two of these, then one of these, if you're subtracting one of them, you'll be left with only one of them. So we are going to be having 6 cos x, then 4 cos that, then therefore plus this one, then this is c sine 6x, then sine 4x, then don't forget to add that one as well, then 2 sine squared x. So at least our expression is reduced a bit. Now, what do you notice? You notice that you really need to break things down again. Now, what if we can break 6 to be in terms of 4 and something else? Because we really need to break it down, because we still have all the sort of thing. We really don't want to take this one back to the compound angle, because it's going to go back to its original situation. Now, let's break this 6 to be in terms of 4 and 2. How about doing that? We're going to be having then cos 6. No, it's going to be 4x plus 2x. Then times, let's just leave this one as it is for control. Then let's get this one. We can also change this 6x to be in terms of 4. We have sine, then we have 4x plus 2x. Let's just write this one as it is, because we don't want to change 4 anyway. So then plus 2 sine 2x. Now, this is what we have. So what do you notice? How about expanding this one now? Let's do the expansion so that you see whether there are some things that are going to cancel out after that. Now, let's expand this compound angle. So we are going to be having cos 4x, then cos 2x, then minus, then sine 4x, then sine 2x. Let's just have all this multiplied by this 4 cos 4x, because we really don't affect that one. Then we have cos 4x. So we are done with this expansion. Let's come to this one. Then plus, let's expand this sign 4x plus 2x. So expanding that one, it is going to lead us to, actually we are going to be having sine 4x, then cos 2x. Then remember that on sine we keep the sign as it is, then we have cos 4x, then sine 2x, then we have that. And don't forget to effect that one, then sine 4, then sine 4x. Let's just have sine 4x there. But don't forget to also add this one, because really this one is just added there. Okay, now what are we having next? Let's do the distribution of this common factor. So let's have cos 4x this times that, which means you'll be having cos squared 4x, then cos 2x, because when you say this times that, you get this one. Then therefore we also have this times that, which is going to be negative cos 4x sine 4x, then sine 2x. Then we are done distributing this cos 4x. Let's come to this side now. Let's distribute this sine 4x to here and here as well. So that means we are going to be having plus sine 4x, we are going to be having sine squared 4x, because we have this 4x and this 4x. That gives us sine squared 4x. Now we are going to be having times this cos 2x. Then after that we will be having plus, which is this part, and times that, which is going to be cos 4x, then sine 2x times sine 4x. So this is what we have. Then let us not forget to also add that one. So adding that one plus 2 sine squared x. I'm just running out of space, otherwise just get to what I'm trying to show here. So what do you notice? I notice that we are having this one over there and this one. Are they not the same? They looks the same, and fortunate enough they are the same. So which means we are having negative this plus this, that they are going to just give us 0, just 0. So we are going to be reducing our things now, which means we are having cos squared 4x, then cos 2x, then plus that one, which is plus sine squared 4x, then cos 2x, then plus this one now, plus 2 sine squared x. So this is what we have. So fortunate enough to these ones, we can see that there is something common, which is cos 2x and cos 2x. So we can take it out. Now what are we having? We have cos 2x, then take it out, we'll be left with cos squared 4x. Then this side you'll be left with plus sine squared 4x. Then don't forget to add your constant over there, which is sine x. So because you remember the identity here, this is just equal to 1, which means you just have cos 2x, this is cos 2x times 1, then plus, that's 2 sine squared x. Not yet there. Let's just try to change this double angle to be in terms of sine anyway, because we already have sine here. So this can be changed to be 1 minus 2 sine squared x, then plus 2 sine squared x, which is this one. Then we are done. This one is just equal to this one on its own, so we have changed it to be in terms of sine. But you can see that this and these are like terms, so you can add them together, and you can see that they are additive inverse, they can just give you 0. Then at the end of the day, you're just left with 1. Indeed, you have to prove that this whole side is equal to 1 over there. So which means the left hand side is indeed equal to the right hand side. So we are done with this proof of this identity. Thank you for watching, and see you right in the next video.